types and properties of quadrilaterals. So a quadrilateral is just a four-sided polygon. And they can be convex or non-convex. So what does that mean? So here's an example of a convex quadrilateral where all the interior angles are less than 180 degrees. And a non-convex one, quadrilateral, might look something like this, where you can see one of the interior angles is greater than 180 degrees. So this one here we call convex, and this one is non-convex. Let's look at all the different types of quadrilaterals we can have. We can have a square, there's a lot of properties of a square, so let's have a look at them. All sides are equal, all angles are 90 degrees, diagonals bisect the angles, the interior angles, and that means they cut them exactly in half. So if this is 90 degrees, cutting them in half means that they're 45 degrees each. Diagonals also bisect each other, which means that they're equal, and they're equal, and they all equal each other. Diagonals also bisect at right angles. So there's all right angles in the middle there. All right, let's look at our next quadrilateral, a rectangle. So rectangle also has a lot of properties. So forgot to mention on a square that opposite sides are also parallel to each other as well. So it's rectangle, opposite sides are equal, so those equal those, and those equal those, but they're not equal to each other. Opposite sides are also parallel, so that's parallel to that, and that's parallel to that. All angles are right angles. Diagonals also bisect each other. And that's what we have for a rectangle. And let's look at a rhombus, which is just a tilted square. Okay. Let's look at all the properties for a rhombus. So yes, opposite sides are parallel. Let's draw those in. Every side is equal. Diagonals bisect the angles at the edges. So that angle equals that angle, and that angle equals that angle. Diagonals also bisect each other, but the lengths of the diagonals are different for each diagonal, because this diagonal is longer than this diagonal, unlike the rectangle where the diagonals are equal and the square where the diagonals are equal. Also, diagonals bisect each other at 90 degrees, just like the square. Let's look at a kite. This is our kite. Okay, we have adjacent sides are equal, so those two equal those two, and those two equal those two. and the diagonals also bisect each other at 90 degrees. The last one is a trapezium. Forgot to mention on the kite that it does have one pair of opposite angles that are equal as well. So this one equaling this one. And this angle equals this angle, so that diagonal bisects there, and that diagonal also bisects there, so that angle equals that one. All right, back to our trapezium. Trapezium only has one property, where it has one pair of parallel sides opposite each other, only one pair. Sorry, I forgot to do parallelogram, so let's do parallelogram. Do it on our next page. So parallelogram is just a tilted rectangle. So parallelogram. Okay, parallelogram has opposite sides that are equal, so those two and those two, opposite sides that are parallel, and diagonals that bisect each other. But they're not equal because the diagonals are of different lengths. Let's look at a special property with quadrilaterals. So in any quadrilateral, all four angles inside always add up to 360 degrees. So A plus B plus C plus D will always equal 360 degrees. And any quadrilateral that has a pair of parallel sides, like a trapezium or parallelogram, square or rectangle, also has co-interior angles. So in this case, A plus B would equal 180, and C plus D also equals 180 degrees, because they're inside the parallel lines. Let's have a look at some examples. So we've got 90 degrees here, X, 80, and 40, and we're going to find the value of X. Well, we know all four angles have to sum up to 360, and we know three of them, which means we should be able to find the last one. Because X would just equal 360 minus 90 minus 80 minus 40, and if we do all that, we should get X equaling 150 degrees, because the angle sum of any quadrilateral is 360. Let's look at another one. So here we're given a kite. We've got X, Y, 110 degrees, and 40 degrees, and we want to find X and Y. Well, the first thing we can do is find X, because we know the property of a kite has one pair of angles that are equal. So x is 110 degrees. Now we know 3 of the angles, so we should be able to find the 4th one, knowing all 4 angles sum to 360 degrees. So y is just going to equal 360 minus 110 minus 110 minus 40, and if we do that, we get 100 degrees for y. Last example. We're given a parallelogram where we know opposite sides are parallel and also equal, and we've got 115 degrees, B and A. We have to find A and B. Well, in a parallelogram, opposite angles are equal. So we know A equals 115 degrees because our opposite angles are equal. And we also know in between two parallel lines we have co-interior angles and they have to add up to 180. So B has to equal 180 minus 115, and we're going to get 65 degrees because of co-interior angles.